So you know that you need to make your websites responsive, but what does that really mean? Well, basically, you want your website to look good no matter what device it's displayed on. Phone, tablet, desktop monitor, really large desktop monitor, you get the idea. To make your website responsive, you need to write CSS styles that'll change the appearance of your website depending on the screen size. Of course, writing the correct styles is a lot easier said than done, but don't worry because in this video, I'm going to show you how to make text elements, images, containers, and layouts on your website responsive. I'll be covering approaches that use media queries, as well as other methods that don't need them like the CSS clamp function and some flexbox and grid styles. Also, this video is sponsored by IBM TechXchange, but more on them later. Alright, let's get into the video. Alright, so before we get into all the style stuff, there is actually one really important thing that you need in your HTML. Otherwise, your website is not going to look good on all devices, no matter what you do in your CSS. So in the head of your HTML file, you want to have this viewport meta tag, and you want the content attribute to be set to width equals device width, and then initial scale set to 1. So what this does is that it's going to tell the browser that the size of the viewport width should be set to the size of the device's screen if you're on mobile, or the size of the browser window if you're on desktop, measured in CSS pixels. So if you're viewing the website on an iPhone, the viewport width is going to be 375 pixels. Or if you're viewing the website on a desktop computer, the viewport width is going to be larger, whatever the size of the browser window is, which could be, 1200 or 1440 pixels wide. Now, usually if you start with boilerplate HTML, that viewport meta tag is going to be included automatically. But if you don't have a tag for whatever reason, then your browser may set the viewport width to an arbitrary number like 960 pixels. So if you load that website on your mobile device, it's going to look weirdly zoomed out because it's essentially trying to load a desktop with website on a much smaller screen. So in order to have your website properly displayed, no matter what screen size you're using, you do need to make sure that you have that viewport meta tag in your HTML head. All right, so all that aside, now let's get into writing our responsive styles. For text elements, usually what we want is to have the text smaller on mobile devices and larger on larger screens like desktops. This is because with phones, the distance from the screen to your eyes is going to be a lot smaller than if you're on a desktop computer, and the distance from the screen to your eyes is larger. So the farther away the website is from you, the larger the text is going to have to be in order to be readable. This is also why billboards have to be giant sized so that drivers can read them from, really far away. So for text elements, the most basic approach for responsiveness is to set a font size for your default mobile styles, and then use media queries to increase the font size for larger viewport widths. So in this example, we have an H1 tag, and it is 2 rems, or 32 pixels on mobile, and then we have a media query for 40 EMs, which is 640 pixels, which increases the font size to 3 rems, and then starting with desktop widths at 960 pixels, the font size is even larger at 4 rems. And this works, and it is a perfectly fine solution, but if you don't want to have, these multiple media queries, another solution that you can use is to use the CSS clamp function. So the CSS clamp function, which I'm looking here on the MDN website, it takes 3 parameters. So the first parameter is the minimum value, and that's going to be, the minimum size that will be allowed. The middle number is what's called the preferred value, and a lot of times you're going to see relative units in here like viewport widths, and this will make it change based on your viewport, going up and down. Then the last number is the maximum value. So you can sort of try to write your own clamp function with the minimum, maximum, and then getting that middle preferred size. But I found that it's just a lot easier to use online tools for this. So one of my favorite tools to use is this clamp calculator or fluid typography calculator, because all you have to do is input the minimum font size, max font size, and then minimum and maximum viewports. And then it just kind of works because it will use math and it'll output the final styles that you can just copy and paste right into your styles. So I'm going to basically replicate what we had done earlier with our sort of more traditional media queries styles. So we're going to go from 2 rems minimum to 4 rems of maximum. So minimum font size is going to be 2 rems, max font size is 4 rems, and then the minimum viewport is let's say 375 pixels. And then the maximum viewport, this is the point where we want to hit that max. We'll just use the 960 pixel from our media queries. So now we have our font size. So I'm going to copy this. And then I can basically replace all of these styles with media queries with just the font size using clamp. And then we have this fallback. This is for older browsers. So if they don't support clamp, which should be pretty uncommon because clamp is really well supported nowadays. If it doesn't support it for whatever reason, then it'll kind of fall back to this original font size of 2 rems, which is the minimum size. So now when we save that and we look at our website, we can see that the font size starting at iPhone width is going to be 32, about 32. And then as we increase, you can see that it just fluidly scales up. So this is another nice kind of side effect of using clamp, where the type is just going to sort of fluidly increase instead of staying the same and then just kind of jumping to the larger sizes. But that's just a little, I think, nice to have. It's not completely mandatory. So, I really do love this fluid typography calculator, and I use it all the time. So I do have it linked below in case you want to try it out yourself. All right, now onto responsive images. Sizing images is a little bit more tricky than sizing text because you also need to keep in mind the size of the original image file, like the JPEG, which is also called the intrinsic size of the image. So in our example here, we have some headline text, and below that we have an image of a cat, but it's really huge and it's causing this horizontal scrolling, as you can see. So to help prevent this, there are some styles that I personally add to all image tags to start out. So for your image tag, what you can do is set a max width to be 100%. So this means that it's going to prevent the image from being larger than its container, overflowing and causing, this horizontal scrolling. So if we save, the image is not overflowing. However, you can see it's kind of skewed. So another thing that I usually add is set height to auto. So this means that the height is automatically going to adjust based on the width in order to maintain the aspect ratio of the image so, it doesn't look skewed like this. So when we save, now the cat image looks normal. All right, so another really important thing to keep in mind when you're working with images is you want to make them as lightweight as possible, meaning, the smallest size, which will equate to a smaller file size for your user. And this will help save bandwidth on your server and also for your users, especially mobile users who might be loading your website using, mobile data instead of a Wi-Fi connection. So one way that you can do this is to make sure that the image files aren't, a ton bigger than they actually are going to be on your screen. All right, so in this example, we have the cat picture, and then we have a headline and paragraph below it. And we also have some styles here that are limiting the desktop content to be 960 pixels wide. And this is what's causing the image to also be 960 pixels wide. So if the image is not going to be any larger than 960, you might think that you can just have, your JPEG be 960 pixels wide and call it a day. However, there's another thing you need to factor in, and that's the DPR, or the device pixel ratio, of the screen sizes that your users might be using. So basically, there are 2 types of pixels. You have the device pixels, which are the actual physical pixels that are on the screens of, mobile phones and desktop monitors. And then you have CSS pixels, and those are the pixel units that are used, on the website to measure the viewport. So back in the old days, one CSS pixel used to equate with one device pixel. So they were basically the same. The ratio was 1:1. This means that your monitor screen might have been 1024 pixels wide, and then it also had a viewport of 1024 CSS pixels. However, as technology improved, as it always does, the ratio of device pixels to CSS pixels changed, and this all started with the Apple Retina screens. So these high-resolution screens had pixels that were half the size that they were before, and so they were able to fit, 2 pixels wide and 2 pixels tall in the same space that previously was just one larger pixel. So with these higher resolution screens that could fit 2 pixels, the DPR was now 2:1. So you can see this comparison in this close-up image of a regular display on the left, and then you have the newer Retina screen on the right. which has the higher DPR. So you can see the Retina image looks a lot smoother and higher quality than the image on the left. And this is great, right? However, for web developers, in order for the images to look good on these higher resolution screens, you needed higher resolution images. Otherwise, the images would look pixelated on these Retina screens. So, for our cat image that is going to be 960 CSS pixels wide, we want the image file to be double that width, so 1920 pixels wide instead of 960. And this is just for a DPR of 2. And there are devices, I think mainly mobile devices, that have even higher DPR numbers, like up to 4. But to be honest, from what I can understand from reading, the human eye has a harder time distinguishing between, DPR of 3 or 4 versus, 1 to 2. So I think that in general, if you just stick to 2x images for your website, you should be fine for most cases. Now, another thing that you might want for your mobile users is to actually have a different image for mobile. So for example, if we're on a desktop size display like this, we have the cat image, we can see it fine. But if we switch to a mobile view, the image of the actual cat on the screen just seems a little bit smaller. So in some cases, you might want to have a more zoomed in image that sort of crops to the cat, so the cat itself will look larger on the screen. And this might sound kind of advanced, but you can actually do this in your HTML using the HTML picture tag. So in our HTML file, which I have here, let me show you how this looks. So I'm going to add a new picture tag. And in the picture tag, we're going to have a few child elements, but you want the last element in the picture tag to be your original image tag. And this is basically going to serve as a fallback image. So if something goes wrong for whatever reason, you're going to have this image tag to be your fallback. Now, to display different images for different devices, what we want to do is add a source tag inside the picture tag. And I'll choose source with media. So this might look familiar. This looks like a media query, right? So this is pretty cool because you can set your media query condition in here. And so let's try to set our min width to 40 EMs or 640 pixels. And then in the source set is where we're going to load the image. That will be loaded if the device viewport width is greater than 40 EMs or 640 pixels. So what I'm going to do is I'm going to copy the cat 1920 JPEG, which is that larger image that we want for desktop. And I'm going to paste it in the source set attribute. And for the source tag, you can also set width and height attributes, just like you do in image tags. And you want to do this anytime you're loading an image because it will let the browser know what the aspect ratio of the image is. So the browser will know how much sort of vertical space to leave in the website while the image file might still be downloading from the server. And this will help prevent content shifts while the website's loading. Okay, so this is for the desktop image. So now let's load the different smaller mobile image in the image tag itself. So I pre-made this image, but it's called cat crop. And if I load it, let's get the attributes here. Tell us here that it is 1200 by 815 pixels wide. So we will adjust 1200 width by 815 for the mobile image. All right, so let's save and see how that looks on our website. All right, so now on our website, on the iPhone view, we have, the more smaller cropped in image. And if I increase the viewport width, it changes right when we hit 640 pixels, which is that 40 EM breakpoint that we added. And for larger viewports, we have that larger image. So this is really nice because the smaller image is not only cropped, but it's also going to be smaller, so you can have a smaller file size for mobile users, so they don't have to load the giant 1920 pixel image. All right, so let's take a look at elements that contain content now. So when you're sizing elements that contain text content, I would usually try to stay away from setting static width or heights because doing this can often cause overflow issues. So here's one example. So I have these 4 cards and I'm using grid to style them so that they have 2 columns. And I've also set the height of all the cards to 175 pixels. Now, you might think that this is a good way to make sure the cards are all, the same consistent height, but this does cause issues as the viewport gets narrower. So you can see as the viewport gets smaller, the text is starting to wrap because we're running out of horizontal space. So as the text wraps, it makes the text taller, it grows in height, and because we set the cards to that static 175 pixels, the text is now starting to overflow, and this obviously does not look good. So if we remove that height style that we set, now things are not overflowing anymore and it does look better. But if you do want to have the grid children be the same height, one trick that you can do is to set on the grid parent, grid auto rows, and set it to 1FR. So what this does is it's going to size all the rows in the grid to be the same height as the tallest grid child, which in our case is this first card. So this is pretty nice because, now the cards can grow and they can shrink in height, as needed. And as we get down to the mobile width, you can tell that things are starting to look pretty cramped. It's not really readable because the lines of text are super short. So this actually brings us to our next section, which is styling responsive layouts. But before we get into that, I wanted to mention today's sponsor, the IBM TechXchange conference. AI is more than just the buzzword of the day. Artificial intelligence has actually been a core focus for IBM for decades, with breakthroughs in machine learning and natural language processing seen in their pioneering Deep Blue and Watson supercomputers. And now IBM is hosting the ultimate learning event on all things AI this October in Las Vegas. IBM TechXchange is an immersive learning experience designed for developers, data scientists, open source enthusiasts, IT architects, and more. It'll include talks by speakers from IBM, Meta, Red Hat, and other companies, deep technical sessions, and networking opportunities. In addition, attendees will get hands-on experiences with instructor-led labs, hackathons, and coding challenges in Watson X, IBM's AI and data platform. Stay ahead of AI tech trends and connect directly with IBM's product leaders in order to enhance your skills and efficiently solve your business's problems. You can get a 35% discount on tickets with my code JOINJESS at TXC. Link to the conference is in the description below. All right, back to the video and responsive layouts. Now, by layout, I mean how you can use CSS to arrange the elements on the page in the order and the position that you want. So generally for websites, what that means is that on larger viewport widths like desktop, you can have more elements fitting on the same row. So we have 4 cards and they're all able to fit together on the same row. But then as the viewport gets more narrow, we start running out of that horizontal real estate. And then at some point, the card content just gets really narrow and it really affects the readability of the text. So what we want to do is for smaller viewports, we want to write new styles so that the cards can, look more readable and fit better on the page. Now there's multiple ways that you can accomplish this, but usually for a layout, your options are going to be either using CSS Grid or Flexbox. But how do you know which one of them you should use? Well, I'm not going to get super in-depth into Grid and Flexbox in this video, but generally, each option is going to behave just a little bit differently because CSS Grid and Flexbox have kind of different approaches to how they position and arrange elements. So I'm going to just kind of use this example with the cards and show you what the difference is between Grid and Flexbox approaches. So we're already using Grid for these styles, so we're going to start with the Grid approach. So what we want to do is we want to change the Grid template that we have for smaller viewports so that we have fewer columns on those smaller devices. And one way we can do this is by adding media queries. So in our styles that we have here, usually what I do is we do what's called a mobile first approach, which with the styles means that our default styles that are not in a media query are going to be our mobile styles. And the reason for this is that usually, but not all the times, the mobile styles and the mobile design are going to be a little bit simpler, meaning you're not going to need as many style rules as you are going to need for desktop, which may have a more complicated design, which will require more style rules. So that way you don't have to cancel out rules in your media queries from your original styles. And there are exceptions to this, like, for example, hamburger menus, which are just for mobile, are going to be a lot more complicated style-wise than the desktop menu, which might just be, a list of horizontal links. All right, so in our case, what we want to do is we want to make the initial grid template columns just have one column. And we're going to make that one column be 1FR, meaning it'll take up all available space. So let's save that style. And we're going to change our view to use the iPhone view. So this has the iPhone with the viewport width of 375 pixels. And again, we have the grid auto rows of 1FR, which is what is making the cards all the same height. All right, so as the viewport width increases and we get to more tablet sizes, the cards are starting to get pretty wide. And I think at this point we can probably fit 2 columns of cards on a row. So let's write our media query. So at media, and we'll set the width to be greater than or equal to 40 EMs, which is also 640 pixels. So the 40 EM or 640 pixel viewport width is going to be our breakpoint. So this means that's the point at which we're changing how the design looks. So here, I'm going to take the grid template columns and we'll just paste it in here. Instead of 1 column, we want 2. So I'm going to write repeat 2 for 2 columns, and each of them will be 1FR, meaning the space will be divided equally between them. So now we can see on tablet we have 2 columns. So in the same way for desktop, we want to increase the number of columns because, there's more space and, we don't want the cards to get super wide. So in our styles, I'm going to duplicate our tablet styles and we're going to use a wider breakpoint. So instead of 40 EMs, I'm going to go 60 EMs or 960 pixels. And here we're going to go to our original 4 columns in our grid template. So, this works pretty well. We go from 4 cards to 2 cards and then 1 for mobile, and things work. And this is a pretty classic responsive design approach because we're using media queries. However, you can also do pretty much the same thing without media queries using grid autofit and the min-max function. So we can actually, maybe I'll just comment out our media queries here. And we're going to start writing our styles for in our mobile styles or our default styles. So using the autofit and min-max approach is basically going to let the browser decide how many columns you want at any given viewport instead of, explicitly designating it yourself within the media query. It is pretty cool because we don't need media queries for this, but there are some downsides, which I will be showing you in a little bit. So in our grid template columns, we're going to use the repeat function. And instead of setting, a static number like we did before, we're going to set the number of columns to auto fit, meaning the browser is going to get to decide how many columns there's going to be in each row. Then for our column size, we're going to use another function, the min-max function. So the min-max function takes 2 numbers. It takes a minimum size and it takes a maximum size. So for the minimum size, let's set it to something like, I'm going to say 15 rems, which is 240 pixels. Then after the minimum number, add a comma, and then we want to set a maximum number, and I'm going to set the max to 1FR. So usually when you do min-max, you do want to set one of the numbers to be a more static number, and then the other number is going to be a kind of relative number. And in our case, the 1FR is the more relative one because, it'll take up whatever available space there is. All right, so now we've saved our styles. And now on our website, I have a viewport width of about 1100 pixels wide. And we have 4 columns. And if we look in our styles, each of the cards in the layout tab is 259, so about 260 pixels wide. So what's happening here is that the browser is going to try to fit as many columns of the minimum size, which again was 15 rems or 240 pixels. It's going to fit as many 240 pixel wide elements in that row. And because it can fit all 4, it's able to fit 4 cards. And then because of our 1FR maximum size in our min-max function, each of the cards is then allowed to grow to fill all the available space. So if I didn't use min-max and I just used 15 rems or 240 pixels, you can see that the cards can all fit, but they are not growing, and they're each going to be 240 pixels, as you can see down here. So using that min-max with the 1FR allows them to stretch to fit, which is usually what people want. All right, so let's see what happens as the viewport width decreases. So you can see initially the cards are just getting narrower, and then at one point when it can't fit the 4 cards of 240 pixels, it's going to start wrapping the cards so that we then have just 3 cards per row instead of 4 like we did earlier. So you can kind of see right where it hits, the card width is that 240 minimum number from the min-max function. So they're all 240, and then as the viewport width continues to decrease, they just can't fit anymore with keeping that 240 pixel minimum. So that's why they start wrapping. And then now, because we just have 3 columns, then the cards are larger, 316 pixels, and we basically just do the same thing. So the cards continue to get narrower and narrower until they hit about 240 pixels, or exactly, I should say. And then once there's no more room and the cards can't decrease anymore, then again, they start wrapping so that we now have 2 columns instead of 3. And then the same thing happens as we go down to mobile. As soon as it can't fit anymore, then they wrap to just 1 column. So, this does work. And it's nice that you just have to write, one style rule like we have here instead of having the multiple style rules and the multiple media queries. However, you may have noticed this, but the downside of this is that because we're letting the browser decide how many columns are going to be in each row, we don't have control over this. And in my experience, when we had designs like this where you have cards or some items, usually people did not want to have an uneven number of items. So for example, this is not really desirable. The client or whoever is on the internal team, they wouldn't want to have 3 cards in one row and just 1 on the second row. They want to go from 4, not have 3, but just go from 4 directly to 2 and then to 1 because things look more even this way. So unfortunately, you can't have that level of control with AutoFit because, again, you're letting the browser decide. So anytime this happened, for me at least, at work, I would end up having to use media queries because, this is what people want. They want to go from 4 columns to 3, from 4 to 2, not 3, and then down to 1. So just kind of a heads up if, I know people these days seem to try to not use media queries as much, which makes sense because they can be done not well. Like if you have way too many media queries and way too many breakpoints, more than you really need. But media queries do let you have more control over how the website behaves. So I just wanted to mention that. Now you can also use flexbox to style these cards. And as I mentioned, it will behave a little bit differently from how grid will. So in our styles, maybe I'll leave our grid styles, but I'm just going to comment all of them out. And what we're going to do is we'll keep the gap property. I'll comment this out too. There we go. But we're going to change to display flex. So now when we save, you might notice that just by having display flex, we have all the cards in one row. And this is a default behavior of Flexbox where when you just add display flex on the parent, it is automatically going to try to fit all the direct children of that parent in the same row. And another thing you might notice is that the cards are different widths. So this card, the first card, seems to be, much wider than the last card here. And this is another default behavior of Flexbox because Flexbox, they don't have, this template like Grid does where you're sort of forcing the children to conform to it. Flexbox is just trying to fit the children, in the website. And so it is very much based on the size of the content in each child. As you can see here, all the cards are different widths. Whereas with Grid, you create your template, you probably make the columns all the same size, and then the cards just kind of conform to that. So this is a pretty big difference between Flexbox and Grid. However, with Flexbox, if you want, you can make all the children the same size. So what you can do is you have to set the style on the child. So I'm using the card class selector, which is for each of the 4 cards on our website. So we can set flex to 1 on the children. And if we save, now the cards are all the same width. Now, how do we make this layout responsive? Because as it is, if we decrease the viewport width, the cards get narrower and narrower, but at some point it starts overflowing when the cards can't get any more narrow due to the size of the content, like, the words here. So how do we make this layout in Flexbox responsive, kind of the same way we did with Grid? One thing we can do is we can let the cards wrap. So again, you want to set this on the parent. So by default, Flex Wrap is set to no wrap or not to wrap. And if we want to turn on wrapping, we need to explicitly set that in our styles. So I'm setting Flex Wrap to wrap, and we save. And then let's see what happens when we decrease the viewport width. So the cards are getting narrower. And then when they can't get any more narrow, then they start wrapping. And you might notice this is a lot different from the way the Grid was wrapping, because before with Grid, the cards, the columns will all be the same width, even on different rows. But with Flexbox, again, we're not using a template of any sort like we are with Grid. We're just trying to fit the children. So the default behavior of Flexbox is for the children to, when wrapping's allowed, it'll start wrapping when they run out of space. And they're also going to grow to fill the available space on the row. And then if we keep going, we'll have, 2 columns of cards. And you might notice that here, the columns are actually different widths. So again, there's no template with Flexbox. Everything is really based around each child. So this behavior, we set the child on the child selector flex to 1. So flex is actually a shorthand property, and it's short for flex grow, flex shrink, and flex basis. So when we set flex to 1, what the browser did is it assigned that 1 to flex grow. And then I think flex shrink of 1 is just the default value of flex shrink. And then flex basis, it'll automatically set flex basis to 0%. So flex basis is the initial size of each child, and then they are allowed to grow beyond that point. So having the initial size, or the flex basis of 0, means that each child is going to grow the same amount, so they will end up being the same size. So that's why setting flex 1 on the children makes them all the same size, versus before, when we didn't have flex 1, and we didn't have wrap, the cards were all different sizes because of the size of the content in them. So one thing that Flexbox can do is break the grid, so to speak, in order to fit the children. So for example, let's say we wanted the cards to be at least 250 pixels and also have the ability to grow to fit the available space. What we could do is, on the child selector, we could set the flex property instead of 1, we could set it to be 250 pixels. So what this does is, if we expand flex, the 250 pixels is going to be assigned to flex basis to be the initial size of each of the children. And then the browser will sort of by default make flex grow and flex shrink 1, so that the cards are allowed to grow or shrink. So you can see that now the cards are going to be, at least 250 pixels, and then they start wrapping, and the last card stretches to fill the available space. And another thing you can do is that if you wanted all the columns to be the same width, for example, you want them all to be 250 pixels, no matter what row they are on, you can do this by explicitly setting flex grow to 0 and flex shrink to 0. And this will then make them always be 250 pixels no matter what. So, you can see this is a much more static and less sort of fluid looking Flexbox arrangement. So, otherwise you kind of let them grow to fit. And that's just really a Flexbox thing. And another thing you may have noticed is that the rows are not the same height. And, whereas with grid, we could use that grid auto row set to 1FR to make all the rows the same height. There's unfortunately no way of doing that with Flexbox. So again, it's like this approach where Flexbox is really just about the children, and it sort of sees each child individually, versus grid has that template, and you can force the children to sort of conform to whatever arrangement and sizing you want. All right, so going back to the saved styles we had for Flexbox, we can sort of do a similar thing like we did with grid, where we add media queries to kind of force a 4-column, then 2-column, then 1-column layout. So let's see how this looks with our Flexbox approach. So with Flexbox, the sizing is set on the children. So let's, I'm just going to copy the media queries we had for grid just to kind of get it ready. And then we'll duplicate our tablet breakpoint, and we want to make the desktop one 60. So for mobile, if we set our view to be iPhone, we want to have one column. So the one way you can do that is set flex to be, instead of 100%. If we save, what this does is it says flex basis on each child to be 100% of the available width. So since we have wrapping turned on the parent, each of the children is going to take up 100% of the available width. So this seems to work pretty well. And then when we get to sort of tablet views here, we want to go to 2 columns. So we can kind of do the same approach. However, there is a little bit of a gotcha, and I'll show you what I mean. So if we want 2 columns, you might think, okay, instead of 100%, let's do 50%, and we'll save. However, we saved, but nothing happened. So what's going on here? Well, hypothetically, the flex of 50% should give us that 2-column layout, but the reason it's not is because of the gap. We have a gap of 14 pixels here, and we didn't factor in that gap space. So what's going on is each card is initially set to 50% of the available space, but then adding that gap, which we would have one gap between the 2 columns, that is making the available space less than what you might think. So there's actually less than 50% available for each of the cards. So if you wanted to be sort of exact about this, you could try to set calc 50% minus, and then so this is for the 2 cards, if you think about the 2 columns, and there's one gap space between them of 14 pixels. So for each card, you would want to subtract half of that, which would be 7 pixels. And then now, if we save, now we have our 2 columns. But, you could subtract, whatever amount kind of works. So for example, if we didn't want to do this exact sort of calc calculation, you could just kind of try to fudge the numbers and choose a percentage that's less than 50. Let's try 48. That seems to work. And then for desktop, we can do a similar thing. If we want 4 columns, we want to set our flex to be, if we want 4 columns per row, then each card would be about 25%, but then also minus the gap. So we would start with 25%, but then maybe do something less, like, 23, if you didn't want to do a calc thing. So, this does work. We have 4 columns on desktop, 2 on tablet, and 1 on mobile. But, it's not super exact. You're kind of just like fudging things. And I feel like if you start finding yourself using a lot of percentages and calcs in your Flexbox, then that's kind of an indicator that you might want to use grid, because you're using these percentages because you want to make the cards conform to a specific size. And that's really more of a grid thing where, you create this template of, you want 1 column, 2 columns, or 4 columns all divided equally. And that might be better to use grid instead of trying to use Flexbox and sort of forcing it to do something that it's not really initially designed to do, even though it does work in the end. So, it can be really tricky knowing when to use Flexbox versus grid. This is really just one example. I do think that in most cases you can use either, but I feel like there are cases where it might be a little bit more intuitive and simpler to use either grid or Flexbox in those cases. But again, Flexbox is good if you wanted to sort of fill all the available space and you don't mind breaking that grid template, whereas grid is if you have this sort of more strict template and you just want to make the children conform to that. So I hope you found this video helpful in terms of being sort of this general overview of responsive styles. As always, thanks for watching, and we'll see you in the next one.